Hey guys, Mrs. Traver here. We're going to take some notes on one-step inequalities. This is sections 3.1 through 3.3. So let's get started. First off, I want to mention the 5 different inequalities and their names. So this one is less than, this one is greater than. And before I move on, let me help you to remember the difference between these two. I think that this will help you to not get them confused when you're trying to read them out loud. This one looks like an L, so that'll help you out. The other one just doesn't. So the one that looks like an L is read as less than, and the other one is greater than. When there's an extra line underneath, it means it's either it's less than or it's equal to. Notice there's kind of a sideways equal than sign. So this is less than or equal to. And similarly, this one is greater than or equal to. The last one is usually forgotten about, but this is also an inequality. Inequality, the prefix in just means not. So this means not equal. So we forget always to add in this fifth inequality. This is just a simple not equal to. All right, so those are the 5 we'll be using. We're going to run through probably 6 examples. They're going to go pretty quick. And the reason why they'll go pretty quick is if you are familiar with solving equations and our methods there, then this is going to be basically the same. There's only one thing we have to watch out for, and I'll show you that too in a couple examples. So let's just first graph some of these guys. So say I started off with x is less than -5. We're going to graph this on a number line. We don't have to give ourselves a million points, but really all I'm concerned with is the -5 and maybe a little bit to the left, a little bit to the right of it. So usually when I do a number line with an inequality, I put the number that x is going to be centered at right in the middle, and then I just do one to the left and one to the right of it. So one to the left smaller than -5 is -6, and one to the right bigger than it is -4. At this point, we can go ahead and graph our point. So we're going to be centered at -5. And when we have a less than or a greater than sign, it can't equal -5. So I don't want to shade in this circle because x can't live there. It's not going to be equal to -5. It is only less than it. So it's only smaller than -5. So I need to shade on the smaller than -5 side to the left. So on this one, we are having an open dot and we are shading to the left. So again, less than and greater than, those ones will use open dots. The next one we'll have one of these, which will do a closed dot. Let's do the next one then. So this one, let's do 12 is less than or equal to b. So again, we're going to be centered at 12. So go ahead and give yourself a number line centered at the number 12. And let's give ourselves one thing to the left, smaller than it at 11, and one thing to the right, bigger than it at 13. All right, so b could be equal to 12. So when I draw my circle in at 12, I'm going to color it in. So it's a closed dot now because it could potentially be equal to 12. And then let's see, let's read this left to right. 12 is less than or equal to b. So 12 is smaller than b. Or I could read it the other way around, actually. I could read it backwards. B is bigger than 12. Think about that alligator math that you did a long time ago where like the alligator eats the bigger number. If you remember that, you put like little teeth in here. You made it look like a Pac-Man. So if you kind of think like that, this little Pac-Man guy is eating the B. So the B is bigger than 12. Or the 12 is smaller than B. So I'm concerned with where B lives. That's what I'm shading in each of these spots. So B is bigger than 12. If I read it backwards, I want to shade in the side that's bigger than 12. Sometimes it gets a little weird when the variable's on the right. Another thing you could do is you could always plug in one of these points to the left and right. So notice if I plugged in 13 for B, if I said, okay, well, let's see, if B was 13, what would happen? We would have plugged a 13 into this B spot. And then it would have said, I'll write it down here, it would have said 12 is less than or equal to 13. Is that true or not? Well, yeah, that is true. So I want to shade on the side where it's true. Notice if I would have plugged in 11, I would have had 12 is less than or equal to b. Is that, oops, I'm sorry. How about I put an 11 in the spot like I said I was going to. 12 is less than or equal to 11. Is that true? Well, that's not true. This is false. So I don't want to shade on the side where it's false. So maybe that'll help out as well. It's kind of weird when the variable's on the right. It's the opposite of what you'd naturally think it should be. All right, so these ones are just a couple where we get good at graphing them. Open dots for less than or greater than, closed dot for greater than or less than or equal to. Let's do some one-step equations ones then. We'll do one of each. So the first one I'll do is add to solve. So I've got x minus 5 is less than or equal to 15. And I want to get x by itself, just like this were a normal equation. That's kind of how we're going to play this, is I'm going to solve all these as if they are normal equations. And then there's only one thing we have to watch out for, which hasn't come up to us yet. So let's get rid of the negative 5 by adding it to both sides. Make sure you keep everything lined up and pretty. Drop down everything you haven't used. So we're going to drop down our x. Drop down your less than or equal to sign, and then solve. So here we go. We've got x is less than or equal to 20, and we'll graph this guy. 20 in the middle. And it looks like we're going to have a closed dot because it could be equal to, and x is smaller than or equal to 20, so 20 is bigger than it. So x lives in the smaller than 20 range, so I'm going to shade to the left. Again, while you're working through these videos, pause whenever you like in order to keep down notes as you go. Let's do example 4. All right, so this one I'm going to have negative 30 is greater than 10 plus a. Go ahead and pause my video and see if you can solve this one and beat me to the punch. All right, let's see how you did. So on mine, I have subtracted 10 from both sides. Negative 30 minus 10 is negative 40. And so if I read this left or right to left, a is smaller than negative 40. So I'm shading on the side that's smaller than negative 40 with an open dot. See if that looks good on your page. Let's do the next one. Example 5, I have negative 6b is greater than 18. So in this example, we're going to run into the first situation where we have something to watch out for. So I'm going to kind of give us a big reminder here. The only thing we watch out for is if you multiply or divide by a negative, something special happens. So if you multiply or divide by a negative, then you need to flip the sign. Or flip the inequality, I should say. All right, so that's the big thing we have to watch out for, is if the step that we're taking, we're multiplying or dividing by a negative, we need to flip our inequality to the other way around. So notice this one, we only have one step, and our step is to do just that. Our step would be to get rid of this negative 6 by dividing both sides by it. And so our math on the left and the right is going to stay just as normal. This b will be by itself, and then this will become a negative 3. So all that is normal, but here, because we multiplied or divided by a negative, we need to change this from being greater than to being a less than sign. So that's a big deal. From here, though, out, we can just graph as normal. So I've got negative 3 in the middle, negative 4 on the left, and negative 2 on the right. Open dot, and b is smaller than negative 3. So shading to the left. We only have one more. I don't know why I scrunched that up. I'm going to come down here. So last one, let's do 10 is less than or equal to a over 3. So on this one, let's get a by itself. I'm going to, again, freeze my screen. You go ahead and try with me. All right, so this last one, see how you did? I have multiplied by 3 on both sides. 30 is less than or equal to a. So reading it backwards from the a side first, I have a is greater than 30. So I'm shading on the greater than 30 side. I hope this looks good to you guys. We're going to go through the next video on multi-step equations as well. Oops, let's stop.